So today we're gonna work on the non-consecutive ones. So let's read the prompt together. The prompt saying given a positive integer n, return an array of all the binary string of the length n that don't contain consecutive ones. For examples, if the input is a 3 and this is the binary string of the length 3 where there is no consecutive ones in the output, and this is another example where the input is 4 and this is the possible binary string of length 4, and again where there is no consecutive ones in the results. So here kind of the constraint for solving this issue. The order of the string in the array doesn't matter, which is pretty cool, and other constraint is to use recursion to solve this problem. So for any recursions or problems, we need to take care of two things: the base case and the recursive calls. The base case, which is the termination case of the recursive methods, where we can stop, which point we want to stop our recursive calls. So the function what's called deepers once, so the or in other words the method it won't bounce out, and then the recursive call, which is case in which method call upon itself. So again, to approach these problems for the recursives, we need to work on they call it the binary recursive tree for these problems. So this tree for the for n equal to, so below is the recursion tree where n equal to. So our simplest case here is empty strings, and then we are going to build up based on this simplest case, which is we're going to add. So let's start from top. Empty string, and then the left branch is to add 0, right branch is to add 1, and we are not gonna add 0 and 1 at the same times because we want to maintain the length of the of our strings, and then we don't need to repeat ourselves. So we add 0 to the empty string, we get 0 plus empty string, which is 0, and then we add another 0. We get 2 zeros here, then we stop. This is our base case where we stop, and then since we stop here, we back it up to the 0, 1 0, then we add 1 0 1. The length of this strings, you see, as you can see here, 2 0, which is the length is 2, and 0 1 the length is 2, so we stop, and again this is the base case. So I hope from here you figure out our base cases, and then we back it up where we add 1 because we said right branch adds 1, then left add 0 1 0, and then the right branch again is to add 1, so 1 1. This one is not acceptable case, so we just ignore that. So that was pretty much about the tree for the problem. So let's start or dive into codings. So here I have my main method. By the way, I'm using Java, and then I'm passing, passing for example 2 to match that. The name of my function is non-consecutive ones. So non-consecutive ones, this is the functions that accept n as a parameters, and this is the n, which is the integer that we would like to generate the binary string for this one. So here is just like building up the array and the size of the array. So the state variable that I need, which is going to be fixed with me, but it's going to be updated with the call, is the result where I wanna push my result to. In this case, I wanna push my result to the array called result of type strings, and then I wanna maintain also the I, which is index of the array, because I want to insert at position 1, position 2, and so on. You're gonna see that. So here I'm initializing and workings on the size. So by the way, here is just declaring the function, declaring the result function, and here initialize it, because here by default is going to initialize it by null. All right, so this is the function, the main functions. And here in the main function, we are not gonna do anything fancy. We just wanna call the helper function, which is, we call it builders here, that accept two parameters, which is we gonna start by empty strings. You see here match empty string, and here is empty string, which is the smallest possible input, and then n. And I need to insert semicolon, and then when it's finished, it should return the result. Okay, so this builders again the string that we want to build, and then n, which is the numbers that I would like to generate the binary representation for these numbers. So two things that I may mention earlier: to base case, which is when I would like to stop, which is, or termination case of recursive method. So you can understand, if you would like to understand the other way, termination case of recursive methods. So where n equal build.length. So if n equal 2, I want to stop where the length of the string is equal to. So, and then when I stop, I want to push the result. For example, if I reach this point, which is 2 zeros, I want to push 2 0 to the result array by saying result of i equal to build, and then I need to semicolon after that. And I wanna increment I wanna go to the next index or position in the result array, and then return. I wanna return this. So this one's going to return. Okay, so if n not equal to length, let's see this example. So for example, where n equal to 1, not equal to 2, that's that reason I need to go deeper, next levels, even by adding 0 or adding 1. So here two scenarios: adding 0 or adding 1. Two branches, it's mean. By adding 0, we can do this one using. Okay, so builders, we're gonna call the function by itself since it's recursive. I'm gonna call the string that I'm building with 0. It's going to be the left branch, and then I'm gonna passing again the n, because I want to check each time the n. However, I can put n as a state variable also. Here for the second scenario, where I wanna build up my string based on 1. By the way, this ones need to be updated also. But before I append 1 to the result, remember, 2 consecutive ones, it's not acceptable in the result. So I want to check if the string that I'm building, the length of it is greater than 0, and the last index it's 1, it's only just return. Otherwise, just call the function by itself and build on 1. Let's see how this one is gonna work. Okay, I forgot semicolon. Okay, just for a quick, it's take time for a quick, and let's start. If you see here, I'm gonna make it bigger. So check. So here, the length of the array is going to be 4, and the initial value is null, and then it's going. You see, it's going deeper. Let me show it to you. So once we reach 20, which is equal to the length of the array, we back it up. We back up here, and then we go to the other branch. See, 0 0 get added, so we get 0 1. Then 0 1 is going to be added here, and I is going to be incremented also, and so on. See, we get 1 0. 1 0 is going to be added here. If you watch out, is going to be added. So this is the pointers that point to the line of code that's being executed at this time. So 0 1, and then added, then call again, empty string, so it's back it up, and this is all the possible value for that. Then here is just going to print it. It's going to print everything to me. Alright, with that being said, thank you for watching and good luck.